Well, my name is Wayne Ward. I'm currently a research professor in the Institute of Cognitive Science at the University of Colorado. I came to Pittsburgh in 1986 following my girlfriend. I had been working as a contractor at AT&T. She graduated and moved to Pittsburgh, so I came here looking for a job. She worked for Jaime Carbonell at the Carnegie Group, and he got an interview with me with Rich Stern. And a programmer position had just opened up in the speech group, and Rich and I hit it off. So he hired me as a programmer in the speech group. Shortly after I got there, DARPA initiated a series of human language technology programs. The idea was they wanted to move beyond the read a well-formed sentence into the system and have it recognize it and actually process spontaneous speech to do a task. And so for this, I was primarily responsible for parsing and dialogue management in the system, and worked with Sunil Asar to build these systems and evaluate it. We were a two-person group. So the big issues that we had to face immediately were conversational speech is not like read speech. There's lots of noises coming in that aren't words. Breath noise, filled pauses, coughing and laughing. And if you ever look at a transcript of what you said sometimes, you'll be astonished. There are grammatical errors everywhere, restarts and repeats and truncated words. I bet somebody transcribed what I said here, I would be surprised at exactly how messy the input is. We also had to maintain a dialogue context to resolve an AFRA. If you said, I want to see it, I had to know what it was, and to ask clarificational questions if there weren't enough information to do what it needed to do. The task picked to illustrate the technology or to build it was an air travel information service. This was a spoken interface to a static database of flight, hotel, and rental car information. You could ask anything about it. Not just flights. You could say, what's the wingspan of a 747? But it was microphone input and text output on a screen. A set of sites, like DARPA tends to do, were funded to develop systems and collect data. All the participating sites would collect and annotate data and put it in a common database to be used for training and evaluation. A Wizard of Oz paradigm was used. That's where the subjects are told they're talking to a computer, but a researcher, unseen by them, is actually controlling the output. What you were judged on is, did you get the right answer out of the database? Weren't worried so much about word error rate or anything else. Did you get the right answer? And if the answer wasn't exactly right, it was wrong. Our approach to the issues we had to deal with for noise was that noise is nothing special. Other noises like fill pauses and coughs can be modeled the same way speech noises are. You can create a lexicon of the events, you can annotate them in data, and you can model them, which is what we did. We also developed the Phoenix robust semantic parser to deal with ungrammatical input. The idea here is to represent the information that you need in a semantic frame and then associate patterns with slots in the frames, word patterns. So here is an example. So for flight info, origin, destination, depart date, arrive date, those are the sorts of things that you might use as constraints to get it. For each of those slots in the frame, called roles now, there was a recursive transition network that was just specified patterns of words that could fill that frame. Each of these patterns were searched for in the input. When one found a match, it instantiated that role in the frame. So here is an example. Do you know when this was made?
1994.
Here's an example of the system at work.
We're going to be demonstrating the Carnegie Mellon Air Travel Information System. This is a system designed to process spontaneous speech from users and respond by retrieving information from a database. Show flights from Pittsburgh to New York. Just JFK flights. I want to go to Denver and I want to leave from Pittsburgh and I want the cheapest flight. The user can be very verbose and very loose in the way they say things, and the system's still able to decode what it is that they want. It's also able to recover from various types of disfluencies and restarts. List, I'd like to see, show me ground transportation in Denver.
In 1998, I left CMU to join Ron Cole and John Hansen to start the Center for Spoken Language Research at the University of Colorado. I had just come here from Boulder and wanted to be in Boulder. If CMU had been in Boulder, nothing would have pried me out of here. And one of our first tasks was the DARPA communicator task. This was a direct follow-on to ATIS, the difference being this used a live database. We scraped Travelocity with users over telephone. So NIST would recruit subjects and they would dial your system up, use it, and then answer a questionnaire as to how successful they were at getting the information they wanted. In 2007, Ron and I started Boulder Language Technologies. We had grants from IAS and NSF for a conversational virtual tutor, my science tutor. So it was to do one-on-one or small group virtual tutor for elementary school science. And if you have not dealt with elementary school kids and speech, you have not had frustration. And now I'm a part of the Institute for Student AI Teaming at CU. The project it's working on is a conversational virtual assistant for small group interaction in elementary school. So you have kids sitting around tables with a tabletop mic in the middle doing a science problem. There are 10 or 12 of these. It's bedlam. So there are always new challenges, but I have to say I'm astonished at where things have come. When I first got here, you would speak a sentence and go to lunch and come back and were really surprised if it got anything right. And now, in the absence of severe noise conditions, I'm really surprised when they don't get it right. I'd also like to say thanks. CMU has a more let the flowers bloom attitude than any place I've ever been. I showed up without a job, looking for a job with no real credentials other than I had a PhD in psychology. And people brought me in, Raj and Rich in particular, and let me do whatever I was able to get done. And there simply were no constraints on it. If you wanted to do it, if you could do it, go for it. It's that sort of attitude that I think makes this such a great place to be. Anyway, thank you.